A warm welcome to panel 1, panel 2 and my supervisor. I am from Faculty of Electrical and Electronic Engineering Technology and my name is Kukanesh Analaki Krishnasamy and my matrix number is B0717105550 and today I am going to present about my bachelor degree project 1 and my project title is Design and Development of Efficiency Increased on Portable Vertical Axis Wind Turbine System for Lighting Application and my supervisor name is Nurul Ashikin binti Mohammad Rais. Okay, the outline content of my project presentation today is introduction, objective, scope of the project, literature review, methodology and preliminary result. Okay, now I'm going to explain about the introduction. Introduction of my project is a wind. About wind. A wind is formed by unequal heating of the surface of the earth from sun, and wind energy is one of the non-conventional form, almost a constant source of wind power on road due to moving vehicles. Wind turbines converting kinetic energy into renewable electricity. When wind spins the blade of the turbine, the kinetics energy captured by the rotor and converts into rotary motion to drive the generator. And also the wind turbines also no need any fuels, transport fuels that can be harmful to the environment. Okay, now I'm going to explain about the two main types of wind turbine. The first type of wind turbine is horizontal axis wind turbine and the second type is vertical axis wind turbine. So as we see on the horizontal axis wind turbine, the wind turbine has three bladed large and also have the main rotor shaft runs horizontally and electrical generator on the top of the turbine. And the horizontal rotates face the wind stream to the capture maximum wind energy, and also the inspection and maintenance is very difficult on horizontal, and also the horizontal extract more power from the wind and more efficient. It also operates in fine and moderate wind speeds. And we're going to see about the vertical axis. The vertical axis have the main shaft rotor arranged vertically and the driver's shaft is perpendicular to the ground. The lift or drag based design and the captures wind from any direction. The vertical axis produces much less energy over time, and the inspection and maintenance is very easy on vertical. The vertical axis also can operate even in low wind speeds. So as an example, in 2005, the Malaysia government, aware of the utilization benefits of wind energy, and conducted a demonstration project for installation of wind turbine in Terumbu Layang with energy capacity of 150 kilowatt. In 2007, the Terengganu state government combines with the Tenaga Nasional Berhad TNP entered on the first solar diesel hybrid power plant projects to supply Perhentian Islands with a combined capacity of 650 kilowatt and the two wind turbines of 100 kilowatt and solar energy around 100 kilowatt and diesel generators which produce 200 kilowatt and 150 kilowatt are built into the plant. System includes backup batteries with power storage capacity of 480 kilowatt. So this is also considered as a first kind in Asia. So the installation wind energy system at housing area or campus area is a great way to lead 100% clean renewable energy. Okay, as we see now, the problem statement of my project is about the problem arises when the vertical axis wind turbine is very in big size. So once it is fixed stationary, it cannot be used in the way it has been installed. So compared to the horizontal axis wind turbine, the power output for vertical axis wind turbine is very low, and the reduce the efficiency level compared to the horizontal axis wind turbine. And vertical axis wind turbine very challenging erect on tower and implementing that are mounted on the base such as land or building. The power supplying wind turbine units has a high cost of developing a wind turbine by government and big corporations. The fabricating can be tricky to ultimate power output to be produced when touching on the low cost advantage. In addition, suddenly if power cuts housing area or working places, to overcome it by portable valve system to produce electrical around 12 watt to 15 watt for the problem. So it is expensive to feed the light house and don't waste some money on inefficient bulbs. From the output can make affordable the best efficient bulb to light up the problem. Okay, the objective of my project is to make the vertical axis wind turbine to portable by reducing its scale and to take any weight and when there is no electricity for high cost on electricity. And the second objective is to provide the electricity from renewable energy for the purpose of usage of lighting a room, at anywhere. The third objective is to develop a portable vertical axis wind turbine to for compare the best light efficient in between the energy efficiency LED bulbs and compact fluorescent bulb and incandescent bulb for a small scale room size. Okay, now I'm going to explain about the scope of the project. The aim of this project is to create a prototype of portable vertical axis wind turbine to study the design and development of the efficiency of vertical axis wind turbine to provide a wind power as output to compare the best efficient bulb to achieve ultimate use of the wind energy at lowest available cost. And the second is to design the fabricate a portable vertical axis wind turbine system which focuses on lighting application. So as the output will generate electricity over fixed output power which produces 15 watt to eliminate the best chosen bulb in a small room scale with appropriate lux and lumen measurements. So this project needs around 1100 lumens for small scale room scale 3 by 2 meters 6 meters square and best efficient bulb. Okay, now I'm going to explain about the literature review that I used. The title of the journal I'm used is Vertical Axis Wind Turbine, a review of various configuration and design techniques. The author of the journal is Bhutta at 2012. The findings of the journal is discussed at the type of blade which I'm used is Darius blade. So the torque of the generation in Darius is different from horizontal axis wind turbine. So the flow of the blades is essentially unsteady and the pulsating flow produces a thrust force which proportional to the geometry of blade and amplitude and frequency. And the Darius blade provides minimum bending stresses in blade. Okay, the second title of the literature review that I used is 7 years wind turbine from Wikipedia source. So the Wikipedia source as the author is Berenzio 1922. So the findings of the Wikipedia source of the 7 years wind turbine, the 7 years wind turbine have solidity but lower efficiency. The 7 years drag force of the wind and the F2 or 3 scoops is an S configured. So the 7 years wind turbine, the curvature reduces the drag when they move against the wind. The cost and durability important more than important the performance. So the 7 years lower power coefficients and aerodynamic performance, and it also has high starting torque and great self-starting capacity. So the third journal I'm used is experimental study of a combined 3 bucket edge rotor with a 7 years wind turbine. So the author for the journal is Lahegi 2016. So the finding of the journal is the edge rotor is the low speed tip speed ratio and inability to self start. The inability to control power output for speed by pitching the rotor blades and also the curved rotor blades, straight blades and connected into the shaft by the struts. So the H rotor also low starting torque but can provide reasonable good efficiency at a high rotational speed. Okay, followed by the another literature review that I used is technical comparison of the domestic LEDs and CFLs available on the Australian market. So the authors is Usman 2017. So the finding of the literature reviews are the LEDs known as a solid state lamps demands on constant current from the low voltage DC. And it is also equipped with a very small buck boost flyback or DC to DC resonant converter to regulate the voltage and current for fed the LED. So the compact fluorescent is a resistive load while capacitive load attached between the voltage and the AC, and the lamp is regulate the current. So the compact fluorescent lamp require the high voltage and current to ignite the preheat filament. So the frequency reduces until the voltage reaches maximum. Okay, the another type of the journal I'm used for finding the lighting literature review is the power quality in modern lighting comparison of LED, micro LED and CFL's clamps. So the authors for the title is Montoya 2020. So the finding of the journal is commonly used model in market LED and CFLs. So the LED is a two semiconductor diode which emits lights. The electrons will later combine with the hole and release a photo shape energy. And the compact fluorescent lamp almost same as fluorescent lighting. Electrons bound to the mercury atom to the excite the states where they can radiate ultraviolet light when they are returning to the lower energy level. So there is use the 16 different types of lamps used in the test. Okay, now as we see the methodology of our part in my project, The methodology use a functional structure. So the as we see the functional structure, the vertical axis wind turbine also have three main points, which is wind harnessing system and power generation system and output system. As we see on the wind force harnessing system, there are drag force from the wind and the blades of the wind turbine rotates. So the power generation systems consist of the DC motor to generate the power, and the power transferred to 12 volt lead acid battery, and after that the power stored and charged as the battery. So the output system that consists of the DC inverter. The DC inverter is to be convert the DC to AC, and the MOSFET in the transformer manage the voltage and the charge is power afterwards. So the load is the lighting bulb, which is chosen by the efficient lighting with fixed volt and watt, which captured by the specific lumens of the final output of this project. Okay, now the flow chart shows that start from the start of the wind turbine, the blade rotation and to the power stored to the battery. Then if the battery fully charged, the circuit will be circuit break, and it will be the end. So if the fully charge is didn't happen, it will be charged to the DC inverter, and it will be converted to the step up transformer 12 to 12 watt, 0.33 ampere, and it is also operates with the MOSFET driver circuit, and the final output will be the light bulb spot, and it is all the last is there will be the end of the flow chart. Okay, this is the selection of the conceptual design of my project. The design I used is in the AutoCAD system, which is the combination of H rotor model and Sevenius model, which has a semicircular cylindrical shape to capture the drag force of the wind. And the lightweight, I'm used a lightweight material for the blade and arms, and it also can generate power from all direction of wind. Okay, this is the circuit diagram for my project. The circuit diagram for this vertical axis wind turbine, the combination of 24 volt wind turbine diesel generator, bridge rectifier, regulator, and battery charger circuit, and also inverter circuit using IC CD4047. But for my multi-sim project, I am using CD4538. So the MOSFET drivers and output stage with connected by 230 volt primary, 9 volt to 9 volt secondary transformer connected in the reverse. So the output will be the connected to the load, which using the lighting bulb ports. Okay, the model parameters that I used for my project is the DC motor, 24 watt 6000 rpm, and the IC I'm used is CD4047, but in multisim I'm used CD 4538. It is similar to the CD4047, and I also used Schottky diode 3 ampere 50 volt, and battery 12 watt of rechargeable sealed lead acid battery, and a diode I'm used is IN4007. It's a 5 units of diode, and the resistor I'm used is 20 kilo ohm. So the light bulb I'm used is LED bulb, compact fluorescent bulb, and incandescent bulb. The transformer that I used is step up transformer that in reverse, and the capacitor that I used is 0.1 microfarad. And in this section, the type of the bulb which is shown on the specifications are LED, compact fluorescent bulbs, and incandescent bulbs. So you can see the watt which is going to use in this project is around to 13 to 15 watts. So the 13 watt LED bulbs need 1100 lumens, and for the compact fluorescent bulb of 13 watt can need 800 lumens, and also the incandescent of 40 watt bulb is needs 450 lumens. So the LED is the most efficient and more effective, flexible, and can last longer. So it can emit light in particular direction, and also longer durability means less green emission. So the LED bulbs last up to the 6 times longer than the other types of lighting. Okay, in this preliminary result, the output that I obtained from the multi-sim for the circuit diagram is 197.243 volt. So this is the output that I gained from the multi-sim. So as measurement from the experimental, this is the result, and for the practical wise, it will be after the project. And that's all from me. Thank you for giving attention for my presentation discussion.